All right, today's November 24th, 2011. We're doing a mid-chapter review. This is from lesson 6.3. This is a difficult question. It's an extending question, so it forces you to think quite a bit. It says, Tara built a sculpture in the shape of a huge equilateral triangle of a side length of 4 meters. So an equilateral triangle is a triangle that has the same side length on every side. Let's say that's roughly properly drawn. Okay, we'll use that as our measurement one. I'm going to put 2 of them up here. I'm putting 2 just so we can refer back to the original, because I'm going to manipulate the second one. So what this means is every side of this triangle is 4 meters because it's equilateral. That also tells us something about all of the angles. All the angles in a triangle have to add up to what? 180. So if they all got to add up to 180 and there's 3 angles, they all have to be the same length. So they got to be 60 degrees. That's right. Okay? So we actually know quite a bit about this triangle. We can answer anything about side length and angle. Now the rest of the question says, unfortunately, the ground underneath the sculpture was not stable, and one of the vertices of the triangle sank 55 centimeters into the ground. Assume that Tara's sculpture was built on level ground originally. What is the length to the nearest tenth of a meter of 2 exposed sides of Tara's triangle? So let's make sense of this. This was our original triangle. Okay? And what we're going to say, we're going to overlap this one. We're going to say one side sank 55 centimeters into the ground. So it looks something like that compared to the original one. And it's sunk. And from the level ground to the corner is 55 centimeters. Okay? Now this is a difficult question to make sense of. What they're asking us is they want to know the distance of the exposed sides. So that would be this side of the triangle and this side of the triangle. Solving triangles, well, it won't be as difficult as this. But this, it's like a riddle, consider it, okay? So they need to know those 2 lengths. Now, I already know one of the exposed angles. What is the exposed angle up here going to be? We know that's 60 degrees. And we know what this exposed side is going to be. Does anyone know? 4. Okay? Now, this is not going to create a right angle triangle. If you notice, this will be the other part of the triangle. This highlighted part will be the triangle we're solving. This is not a right angle triangle. So we'll eventually have to use our sine law. The problem is I don't have enough information right now. I only have 1 angle and 1 side. What? So because we only have those 2, I'm going to have to do some deduction here. And what I'm going to do is I'm going to create another right angle triangle. So I'm going to put some yellow here. That is also a right angle triangle down here. I know it's a little hard to see, but this here is a right angle triangle. We know that this side of it is 55 centimeters. How long is this side of it? Yeah, it's going to be 4 meters. We know that this is 4 meters in length. And here is our trick. Okay? This will be the goal to solving this question. I actually need to find out this angle here. Now, I do know that this entire angle here is 60 of that triangle. But the red angle, I don't quite know. So what I'll have to do in my smaller triangle is find out this angle here. Okay? So this is a difficult question in terms of thinking. We have this angle. We actually have 2 sides of the right angle triangle. I have the hypotenuse and I have the opposite side. So with that being said, that means I'm going to use a sine ratio to solve this. It's confusing us. It's okay. We're not doing it. So because we're using sine ratio, this is our opposite side. This is our hypotenuse. Now the only other thing too is one is measured in meters, one is in centimeters. So we're going to change this to a centimeter question, okay? I'm going to erase my meters, and we're going to convert them to centimeters. We know that 4 meters is 400 centimeters on both of them. Oh, that's 40. Now, our opposite side is 55. Our hypotenuse is 400. We're looking for sine. We're going to call the green angle, we'll call it angle G. You guys okay with that? Because it's green. Now, I need to bring sine to the other side of the equation. Can't see green? Oh, that's unfortunate. Our green angle is going to be equal to the inverse of sine, 55 divided by 400. Okay. Now, 55 divided 400 equals, I'm going to keep that number in the calculator, and I'm going to find the inverse of sine, 7.9. Sure, we can round it to 8. We're going to say it's 7.9, or G is approximately 8 degrees. So what we've discovered is that our green angle is 8 degrees. So if our green angle is 8 degrees, our blue angle is 60. By deduction, how do we find that red angle inside the triangle? I subtract 8 from the 60. So 60 subtract 8 gives us our 52 degrees. So that angle there is 52 degrees. Okay, so finally in this question, you would have this angle, and this side, and you can use sine law to solve for the other side. We're going to move on. Number 5 from page 293. Okay? What they've done is they've given us a boat, and it looks roughly like this. They've even given you a photo of it. We have a main sail. There's a mast, and then there's a boom of the boat. Looks something like that. Okay? So this is our boat. This is the main mast. Now the question tells us that the mainsail, which is the triangle in our shape here, we're talking about this specifically. This is our mainsail. The mainsail of this triangle measures 2.4 meters across the boom. So in other words, they're talking about the bottom part of this triangle. It's going to measure 2.4 meters in length. And 4.4 meters up the main mast. So in other words, they're talking about the height of this triangle. They're saying that the height of this triangle measures 4.4 meters in height up the main mast. And then it says, what is the area of the mainsail? Oh, sorry. The boom and the mast meet at an angle of 74. So we're assuming we're talking about this angle here at 74. We're going to assume this is a equilateral triangle. Or sorry, that's these two lengths. These two angles are going to be the same. So we have 74 and 74. The final question is asking us for the area of this triangle. Oh, that can't be right then. Sorry, I wrote this down wrong. It's 4.4 up the main mast, so I think they mean on the right side of this triangle. So, if our triangle is set up like that, in order to find area of a triangle, we need to find the height of this triangle. So the height will create a 90-degree angle with the bottom of our main sail. The height of this triangle, we're going to say, is in the middle. We're assuming the main sail is a triangle that has two sides that are the same length. So I actually have to find the height of this. Now I have this angle and this length. I'm looking for this side of the triangle. So in reference to this, this will be our opposite and our hypotenuse of the triangle. So I'm going to be using sine law again, or sorry, sine ratio, to set this up. The angle is 74, so we get sine 74 is equal to, our opposite is our x, and our hypotenuse is 4.4. To isolate x, we got to move 4.4 to the other side, and we'll have to multiply by sine 74. So we'll type that in our calculator. Sine 74 times 4.4 gives us 4.2. So the height of this mainsail is 4.2 meters. Now the final question asks us for the area of a triangle. The area of a triangle is 1/2 times the base times the height. Yeah. Our height is 4.2 and the base is 2.4. So we'd use 1/2 times the base, which is 2.4, times the height, which is 4.2. We type that in our calculator. 1/2 is also the equivalent of 0.5. So 0.5 times 2.4 times 4.2. The area of our mass is 5.04 meters squared.
So it's 4.4.
And the answer?
What? I'm so confused. Why is it 4.2?
Question 8. They have a picture of a helicopter that does not look nearly as good as mine. And it says that a searchlight is mounted on the front of the helicopter flying 125 meters above the ground. So we know this helicopter is 125 meters above the ground. So we have our ground, and we know this height is 125 meters. The angle of depression, this is important. The angle of depression of the light beam is 70 degrees. Remember, an angle of depression is always measured off of a horizontal straight line and then downwards. So they're telling us the angle of depression is 70 degrees, which means this angle here is 70 degrees. An observer on the ground notices that the beam of light measures 5 degrees. So the beam of light, this is creating a beam. Okay, so there's our beam. We'll highlight it so we can tell. This is our beam of light. We'll color it in. He discovered that the beam of light measures 5 degrees inside. So that's 5 degrees inside of that beam of light. How wide to the nearest meter is the beam at the bottom? So we're looking for this distance here, okay? Now what I can do is we know that the beam is also going to be 125 meters off the ground, so we'll move this around. So essentially now, I'm going to have 2 right-angled triangles I'm dealing with. We know that this is going to create a right angle, and we'll use our lines to distinguish the two. The first one will look like this. Yeah, I think we'll do. So our blue triangle is the first one we're going to deal with. Now this is what's important. We know the height is 125. I need to find out the measurement of this angle in our right angle triangle. So in order to find that, I can deduce that from our angle of depression to our height above the ground is 90 degrees. I know that the angle of depression is 70 degrees and the beam of light is another 5 degrees. So I'm going to take that 90 degree angle and I'll subtract 70 and 5 from it to find out our new angle inside our right angle triangle. That's going to give us a 15-degree angle. So our angle inside is 15 degrees. What we're trying to find is the distance of this part of the triangle to start. So if we have that angle, we're looking for the opposite side, and we have the adjacent side. That means we're going to be using which ratio? We use tangent. Distance of D. Tangent 15 is equal to x over the adjacent is 125. When we bring 125 to the other side of the equation, we get tangent 15 is equal to x. So, we know that tangent 15, where's tangent? Oh, there it is. Times 125. It's going to equal 33.49. Let's round it to 33.5. So we know the distance from exactly below the helicopter to the start of the beam is 33.5 meters. Now, the other right angle triangle we're going to be working with is actually going to be to the front of the beam. Okay. Now, to the front of the beam, we're going to take out that 5 degrees we subtracted the first time. So we have 90, subtract 70, which will give us 20 degrees. Okay, so our new angle here is 20 degrees. So it's the same type of question. The only difference is the angle we work with tan is 20 instead of 15. So we set up the ratio the exact same. We bring 125 to the other side, the exact same as we had done before, to find out our new distance of x, which is directly below the helicopter to the end of the beam. So, again, we do tangent 20 times 125 will give us 45.49, rounded to 45.5. But the real question is asking us for this distance here. So the distance of D will be 45.5, subtract 33.5. 45.5, subtract 33.5, 12. So the distance of this beam is 12 meters in length. Okay, question number 6 says a Coast Guard's boat. All right, so we have our Coast Guard down here. There's his boat. And he's tracking 2 ships. Here's ship number 1 and ship number 2. At noon, it says the 2 ships are 5 kilometers apart. So these are 5 kilometers apart. Now here's an important wording. I need you guys to pay attention to this. It says the angle between them is 90. So what that means, if we were to make a triangle here, I draw it any way I like. This angle opposite of them is 90 degrees. So the angle between them is 90 degrees. Okay? It says that the closest ship is 3.1 kilometers, so we're going to call this guy the closest, 3.1 kilometers away. How far to the nearest tenth of a kilometer is the other ship from the Coast Guard boat? So we're looking for this. Now I could use this distance. I could find the angles here. But the best way to go about this is to use Pythagoras' theorem for this. Now, the important part about Pythagoras' theorem is the C. You must get the C part right. C deals with the hypotenuse of a triangle. Hypotenuse is always opposite of the 90. So we're talking about 5 in this case. So we have 5 squared is equal to, we're going to call this side A, 3.1 squared plus B squared. I need to isolate B squared, so I'm going to bring 3.1 squared to the other side and it become negative over there. 5 squared is 25. 3.1 squared, 9.61, is equal to B squared. 25 subtract 9.61, 15.39. And then we're going to square root both sides. Which means the distance between the longest point is 3.9.